Ball lightning has been reported for centuries, yet it remains one of atmospheric science's most stubborn mysteries. People describe glowing spheres appearing during storms, hovering, drifting, sometimes darting, then vanishing in seconds. The stories are vivid, but the evidence has usually been weak. Brief sightings, unreliable memory, and low-quality images that tell us less than they seem to. So when a home security camera in Bozeman, Montana, recorded a bright moving object, in August 2023, it drew attention for a simple reason. This was not just another viral orb clip. In 2025, researchers treated the footage as a dataset and published a quantitative analysis in the Quarterly Journal of the Royal Meteorological Society. That does not mean the mystery is solved. It certainly does not mean the video proves ball lightning. But it does mean the clip deserves more serious attention than most internet footage of glowing lights. The Montana video matters because of context, distance, and method. First, the event happened during thunderstorm conditions, and that is a common setting in reports labeled ball lightning. That storm context is one of the strongest points in its favor as a candidate. Second, the object appears to have been less than 10 meters from the camera. That is unusually close for amateur footage and gives researchers a better chance to reconstruct motion and brightness than in most cases, where a distant light is little more than a blur. Third, the authors did not simply react to the clip as spectators. They analyzed visible size, brightness, movement, and breakup, and they judged the object likely to be self-luminous. That combination makes the Montana event one of the most detailed videos of a possible ball lightning case. Even so, the wording matters. Possible ball lightning case, not confirmed ball lightning. In fact, the researchers themselves were explicit about the main competing explanation. A power line arc with glowing metal particles or other burning material cannot be ruled out. That is the central alternative hypothesis, and it is important not to bury it. A dramatic, luminous object near storm-damaged infrastructure can look extraordinary while still having a more conventional electrical origin. The best current description of the clip is careful and limited. It is one of the most detailed videos of a possible ball lightning case in which a power line arc with burning particles cannot be excluded. That kind of caution may sound unsatisfying, but in this field it is actually a sign of quality. Ball lightning research has long suffered from overstatement. Bright nighttime objects are difficult to judge even in person, and video adds its own distortions. One key issue is blooming. Very bright objects on video can spread beyond their true boundaries in the image, making a tiny light appear much larger than it really is. The Montana analysis took that problem seriously. The researchers did not simply assume that the glowing blob seen on screen revealed the object's true physical diameter. Their estimate, uncertain because of blooming, put the object at roughly 14 to 17 millimeters. That is strikingly small compared with the popular image of ball lightning as a glowing sphere the size of a grapefruit or larger. But popular imaginings are not evidence, and many witness reports are less precise than they sound. In darkness, under stress, in surprise, people are not measuring carefully. They are experiencing something unusual and then reconstructing it afterward. Size, duration, and motion are especially vulnerable to memory error. That witness evidence caution is essential when discussing ball lightning more broadly. Human judgment of bright nighttime objects is unreliable. Stress narrows attention. Darkness removes visual reference points. Surprise distorts time perception. Later recollection tends to smooth uncertainty into a coherent story. None of this means witnesses are dishonest. It means eyewitness evidence in these situations is fragile. Still, witness reports are not useless. Across centuries, many accounts do show recurring patterns. Ball lightning reports often involve storms. The luminous form is often roughly spherical. The lifetime is usually short. Colors vary. Motion can appear calm or erratic. These common features give some reason to think at least part of the tradition refers to real atmospheric events rather than pure folklore or misperception. Where the evidence becomes weaker is in the more dramatic claims. Reports of very long lifetimes, long indoor travel, passage through solid materials, or highly precise motion are rarer and much harder to evaluate. Those are exactly the kinds of details that can grow in retelling, and they are also the details that current models struggle with most. So the responsible approach is not to treat every classic ball lightning story as equally credible. That brings us back to Montana. How well does this clip fit the witness tradition? Partially, but not perfectly. The thunderstorm setting fits well. The object's luminous, roughly compact appearance also fits in a broad sense. But its glow appears to fade gradually, while many reports describe abrupt disappearance, sometimes with an explosion or a bang. That mismatch does not disqualify the event, but it does remind us that ball lightning may not be a single, neatly defined thing. And that possibility becomes even clearer when we look at the strongest instrumental evidence in the field. One of the most important cases came from China in 2012 and was published in 2014. There, a luminous event following a cloud-to-ground lightning strike was captured with a spectrograph. This matters because witness testimony can tell us how something looked, but spectroscopy can say something about what it was made of, or at least what elements were emitting light. In that Chinese case, the recorded spectrum showed signatures of silicon, iron, and calcium. Those signatures supported models in which lightning vaporizes ground material, creating chemically active particles, including oxidizing silicon nanoparticles. That is one of the strongest measurements ball lightning research has produced. It ties a luminous event directly to a physical process involving the aftermath of a strike and material from the ground. Even there, though, caution is necessary. A strong measurement is not a universal explanation. Chemical models are attractive because they fit spectra, laboratory results, and the storm context of many reports. But they struggle with one of the biggest questions: shape, stability. How does a glowing, ball-like object maintain a coherent form long enough to be seen moving through the air? This is where electromagnetic ideas, including microwave or maser cavity models and related proposals, enter the discussion. Such models may help explain stability in ways purely chemical models do not. The problem is that they do not yet enjoy broad acceptance for natural storm conditions. In other words, they may solve one difficulty while raising others. The field has plausible mechanisms, partial matches, and laboratory analogs, but not one settled theory that cleanly explains the full range of reports. Laboratory analogs are important in their own right. They show that ball-like luminous structures are physically possible. That matters because it pushes the topic out of the supernatural and into normal science. Weird does not mean impossible. But laboratory analogs are not the same as identifying a single natural cause in the atmosphere. A glowing ball made under controlled conditions is evidence that such structures can exist, not proof that every field report has the same origin. And that is probably the deepest lesson from the Montana clip. Its value is not that it ends the debate. Its value is that it sharpens it. The footage is better than most. The object was close. The storm context fits. The analysis was quantitative. The object was likely self-luminous. Researchers could study brightness, movement, visible size, and break up more effectively than usual. All of that elevates the case well above the average online mystery video. But the central alternative remains alive. A power line arc with glowing metal particles or other burning material cannot be excluded. Blooming complicates size estimates. The object appears smaller than many people would expect. Its fade-out is not a perfect match for some classic reports. So the clip is strong evidence of an unusual luminous event during a storm, and a strong candidate for what people call ball lightning, but not proof. The wider picture points in the same direction. Centuries of reports likely contain a real core, supported by recurring patterns and by rare but valuable instrumental cases, like the 2012 event in China. Yet the diversity of descriptions, the weakness of many eyewitness accounts, and the incompleteness of current models all argue against a simple answer. So, does this video provide evidence? Yes, in the limited and scientific sense. It provides evidence of a possible ball lightning case, and unusually good evidence at that. Does it prove ball lightning as a single known phenomenon? No. The strongest conclusion at present is more plural than singular. Ball lightning may not name one thing, but several different processes that produce similar glowing forms under storm conditions. That is less tidy than a final verdict. but it is also more honest. And for a mystery like this, honesty about uncertainty is the most solid ground we have. Subscribe, enable notifications, and suggest the next topic in the comments.